Hello, my name's Graham Lewis, and in this short video I want to eventually solve some complicated trigonometric equations like number 2 there at the top, but a quick refresher on how to use principal values and general solutions on number 1, because that's the method we're going to do on number 2. So if we remember, we find first the principal value. This is the number the calculator gives us when we do cos inverse root 3 over 2. And of course that's pi over 6 in radians. So the principal value is pi over 6. The reason for that is that for the cosine curve, the calculator only defines the domain from 0 to pi so that it is a one-to-one function, so it's invertible. So your answer for cosine inverse will always be between 0 and pi by 6. Now we know, because the cosine function is symmetrical about the y-axis, the secondary value is always negative the principal value for the cosine function. So it's minus pi over 6. So we've got one going down the roller coaster, if you like, at pi over 6, and one going up the roller coaster at minus pi over 6. Using those two answers, because the period is 2 pi, we can generate formulas for all of the others. So we've got a formula, the principal value, plus 2 pi n, because the period is 2 pi n, plus the secondary value, so x equals the secondary value minus pi over 6 plus again 2 pi n. And we could put values in for n to generate our infinite number of solutions. So that's how to use the principal value approach and general solutions to get formulas which can then generate all of our answers. And we can obviously restrict that in a given domain. Now, the reason to do a refresher on that is because it's exactly the same principle in solving the second one there, cos 3x minus pi over 6 equals cos 2x. So I'm going to treat this right-hand side part here just as a number, like it was root 3 over 2 before. So to find the principal value, I'm going to do cos inverse of the right-hand side, assuming again that the cosine inverse function exists because we've restricted the domain from 0 to pi. Now, cosine inverse of cosine 2x must be back to 2x, because we've done the inverse of the function. So my principal value is 2x. My secondary value for cosine, because it's symmetrical in the y-axis, is minus 2x. So now we can get our two equations. The angle we're talking about is slightly more complicated. It's 3x minus pi over 6, and that has to equal the principal value plus 2 pi n, or 3x minus pi over 6 equals the secondary value, which is minus 2x plus 2 pi n. And now we have a little bit of algebra to do. So working on the left-hand one first, which is slightly easier, subtracting 2x from both sides and adding pi over 6 to both sides gives me the general formula x equals pi over 6 plus 2 pi n. On the right-hand side, adding 2x to both sides and adding pi over 6 to both sides gives me 5x equals pi over 6 plus 2 pi n. And I have the additional step here of having to obviously divide by 5, so I get pi over 30 plus 2 pi n over 5. And there I have the two general solutions, and we can put values of n equals 0, 1, and 2, etc. to generate all the answers. Let's see what that looks like on the graph. So here you can see I've got my two general solutions again, x equals pi over 6 plus 2 pi n, and x equals pi over 30 plus 2 pi n over 5. And I've actually written them as common denominators underneath, so it's easier for me to put values n equals 0, 1, 2 in. So let's put n equals 0 in first, both of them. If I put n equals 0, it gives me pi over 6 in my top one, and it gives me pi over 30 in my bottom one. And we can see on the graph, there's the pi over 30, and there's the pi over 6. So it's generating the same answers. Let's put n equals 1 in. Putting n equals 1 in gives me 13 pi over 6 in the top one, and in the bottom one it gives me 13 pi over 30. And you can see 13 pi over 30 there, and 13 pi over 6 is obviously further to the right. It's not on my graph there. And you're thinking, what's happened? Where's this 5 pi over 6 gone? Why is it not generating that? Aha, patience. Let's put n equals 2 in. If I put n equals 2 into my first formula, I get pi over 6 plus 24 pi over 6, that's 25 pi over 6, and Bob's your uncle. 25 pi over 6, no it's not, sorry. 25 pi over 6, is that on my graph? No, that's obviously to the right. Let's put n equals 2 in the second one. I think this is going to be the Bob's your uncle moment. So pi over 30 plus 25 pi over 30, there we have it. That would be 25 pi over 30. if I put n equals 2 into this equation here, and of course 25 pi over 30 is the 5 pi over 6 I was looking for there. So you can see that this formula does in fact work, and it creates all of the correct solutions for solving cos 3x minus pi over 6 equals cosine 2x. Thank you for watching. This was a challenging problem. I hope you enjoyed it, and you can see the power of using principal values and general solutions to help us solve more difficult trigonometric problems.